helping to explain the atmospheric circulation about the planet and unraveling many of the mysteries that Venus has held. Fortunately, the cosmos arranged it so that we had a ringside seat as Halley's Comet came by in its path closest to the Sun, which is the time when the comet is its most active.
Halley's, like all comets, is made up of several parts. The nucleus is a large, dirty snowball frozen as hard as marble. It is composed of roughly 40% water ice, 10% frozen gases, and 50% dust and rock. When a comet's looping orbit carries it close to the Sun, the intense sunlight begins to boil dust and gas from its surface. Invisible hydrogen gas forms a large egg-shaped cloud called a coma, and the comet develops two spectacular tails, a straight tail made of electrically charged gas and a curved dust tail. At the University of Colorado, Boulder, Dr. Ian Stewart, chief scientist of the Pioneer Halley's mission, determined that he could make unique and valuable measurements of the comet using one of the orbiter's instruments.
In 1983, when we looked into the possibility of observing Halley from Pioneer Venus, we realized that it would come within shouting distance, celestially speaking, and that we could make really valuable measurements of the hydrogen coma. Of the comet was this false color image of the hydrogen coma. The scale is immense. The image that you see is 12 million by 8 million miles. And briefly, during its passage past the Sun, Halley was the largest object in the solar system. The image uses color to represent brightness. The blues and reds are the darker levels of light, and the yellows and greens are the brightest parts of the comet. Well, analyzing the image and other data allowed us to estimate the rate at which water was subliming away, evaporating away from the ices of the nucleus.
Before this last visit, many scientists had assumed Halley's was a relatively fresh comet, so the extent of the erosion and the amount of dark crust on the nucleus came as a surprise. Pioneer Venus observations showed large daily variations, as much as 25%, in the rate at which water was boiling off the comet. The best explanation for this is that only portions of the comet's surface had freshly exposed ice that could act as sources of water vapor. The evaporation rate varied depending on how much of this fresh material was exposed to sunlight as the nucleus rotated.